tutorial. So he will show how do you install Pharo IoT on a Raspberry Pi, how do you do small stuff, like lighting some kind of LED and things like this. Then he will show how to build a small weather station, a small thermometer, and then he will discuss a bit what we want to do in the future. So, Pharo IoT was created at ERMOD over the last 2 to 3 years. And the main engineer behind it is actually Dennis, who implemented Pharo IoT 2016 to 2017. And Alex came to the team this year in May to take over the project with the goal to actually make tutorials and to continue the project. So, what is actually Pharo IoT? So, one view, which is the first 2 lines, to think about it is that it's Pharo, for one, running headless on the Raspberry Pi or on an ARM device in general, and Pharo running on a development machine which remotely controls the IoT device. Another view is that Pharo IoT is a collection of all the needed libraries behind. So, the Pharo on the Raspberry Pi has a library to control all the input-output using Raspberry Pi. We do have a library in addition to touch Arduino devices and talk to them using Firmata, which we will not show today. We have a very nice board model inspector, and the project contains all the code of the remote IDE. And the remote IDE is not only usable for the case of IoT, but you can use it for any other headless situation. So for example, if you have a Pharo image running in the cloud in a Docker installation, you could actually connect remotely a workspace, a playground, a browser, very easily. To come back to the embedded world, to the Raspberry Pi, we always talk about GPIO, and the question is, what do we mean? If you have a Raspberry Pi sitting on your desk, then you see always this line of connectors in the upper part. And this actually is where you can connect other devices. So there is analog input and output, digital input and output, and you can use it to attach to, for example, I2C devices and things like that. So we have that a bit on the next slide. What we actually then have on the side of the code is that we have a library that simplifies modeling boards like that. So for now it's only Raspberry Pi, but the library was created with being portable in mind, so you can actually extend it fairly easily for other systems. What we did when Alex arrived was to actually take the implementation that was only for the Raspberry Pi 1 and 2 and to extend it for the Raspberry Pi 3, which was fairly simple. And so you can see here the hierarchy of the board. What is then done with this library is that we implemented a very nice inspector for the GPIO pins. The idea behind that is that if you look at documentation and tutorials, you always have a view that is a bit similar to this. Only that's, of course, completely dead on your piece of text. And here, it's actually an active inspector where you can click and inspect stuff where actually all these things are live, which we will see later in practice. So, a huge part of this, independent of the Raspberry Pi, is the remote development environment. And I will show just some pictures. We will see later this stuff to some extent live while doing the tutorial. So we do have a remote playground which actually executes, which runs on your local machine, but it executes all the code on the remote machine and you get back a proxy. It's quite interesting how it actually is implemented, because it uses actually to model workspace variables, it uses the feature that we have first class variables in the system. So it kind of defines a new global variable kind to be able to do this. Then we have the remote browser. So the new browser in Pharo 7 was created with this in mind. So the first starting point was to look at taking the current browser and make it remote and that didn't really work out because there was far too much traffic going on. It was really not structured to be doing that, and so the current browser is capable to be browsing the code of a remote machine and to do everything nice, so that you have syntax highlighting and all these things. Then we have a remote process browser, which allows you to look at the processes of your remote machine. And we have a remote inspector, remote debugger. So that means if you have an exception on the remote machine, you can actually debug it locally and inspect everything. And this concludes my introduction, because the main part of this presentation is actually to do a hands-on. So the idea is that the slides have all the information that you need to do these experiments yourself. So we will have a bit of things on the slides that are not directly interesting for the talk, but if you want to redo this, it has everything you need. You should set up that Allex has the hands-free.
Allex, I'm from Brazil. I started in our team this year, and I'm very new in Smalltalk and Pharo, and I started to learn from zero, and I'm very happy to use the Pharo and Smalltalk, and I like so much to work with this. And I will talk a little about, a bit about what I did and what is my challenge to work in PharoThings, and how I connect in Bern using the tools, PharoThings tools, and how I create new class and new codes, and how anyone can do this too. So the first step is the installation. How to run Pharo in ARM architecture. So first step, we need to create one image in the laptop. I create one image in my MacBook, and the PharoThings was split in two sides, the client side and the server side. The first part of the code is to install the remote server, and it's only create one image, and you run the command to install the PharoThings. And the second step is download the ARM VM. So take these files on the ARM VM and put inside the folder of the PharoThings of your image, and copy this to Raspberry Pi, and copy by network or take and put in the flash drive. And after with this folder in the Raspberry Pi, just set the permissions to execute, to run, and the third line is to run with the user interface, and the last line is to run without the user interface. It's just to start the server and that port 40423. You can change this port, and after this you can connect from your laptop to the Raspberry Pi. So I show some stuff now, like control LEDs and sensors and LCD display, and I would like to talk first about my first challenge, because when I start to work with PharoThings, the code was right to Raspberry Pi 1 and Raspberry Pi 1B, 1 and 2, some stuff like this. But I started working with Raspberry Pi 3, and there is no class and hold the YPF to Raspberry Pi 3. And how I did this? It was very simple, because I did the stuffs. I created the image, so download the RPM, starting the Raspberry, and I connected it to create this class. And I did this remotely using the PharoThings tools. And thinking this, I create one little scenario, one demo, and I would like to show now this video. This one video show how you connect it in Raspberry and how create the class remotely, how save the image, and in the video I reboot to show the persistence, and I will show this to you now. This video is the dynamic update. This is the scenario. This video shows how we can dynamically extend the word running on a remote device using PharoThings. The context, to understand the context of this. PharoThings is running in Raspberry Pi 3 Plus, but we inadvertently load it with a version that doesn't have the subclass to control all GPIOs in this model. Should we reboot, restart, to create, to take the plug the LCD to develop? No, this is not necessary. With PharoThings, we can connect and live update live the run device and define a new board while it is running. How? Connect it remotely on the Raspberry Pi 3 Plus with Pharo from my laptop, and I will create a new subclass to work with this model of the Raspberry Pi. So I will save, in this video I save the remote image and restart the server to show the persistence. So I'm connected, I will start the PharoThings in the Raspberry. Now is this in the board, and now this is my MacBook, my laptop. I will connect in the Raspberry, and I will inspect the board. And this board has only 26 pins, because this board is the first model of the Raspberry Pi. So now I'm open the remote browser to see what is inside the Raspberry Pi. What's the class, what's the code, and I found the model of the boards, and now I'm create a new board. It's to model 3B, and I create the initialization to this board. The initialization has all the map, the scheme of the pins, because each model there is different pins, and now with these pins I can control the Raspberry Pi B3 Plus. Because the board is an object, and to create a new board is just to create a new object. So now I can inspect with the new class that I create remotely. So now I have the new board. It's a board with the 40 pins. And now I can use all the pins, the Raspberry Pi 3, with the new class. And then I show I instantiate a new GPIO, the last GPIO, to show this is working. And the last step is the save image. Is now what I did. I did one remotely update and save the image. Now I will restart the device to show the persistence. I can start it quick with our remotely too. Now we start again, just to see, to show the code inside the Raspberry. Okay, let's navigate again to the folder class, code remotely. Yeah, there's my code saved, and I can do this to all the code, and I can create things remotely, I can develop this remotely. And what did you show? What I would like to show you is with PharoThings you can dynamically update in one board. You can interact remotely with pins and boards and modify the system while it is running, create a board, change code, and make your change persistent. And I did this remotely, connected remotely. I do a remote development using PharoThings. It's very easy, it's very powerful. So now I will show live how to do this live. I have here my Raspberry running PharoThings, and I will connect it. Okay, now I'm connected there, and I can inspect the board. Let's open the playground first. I can open the remote playground. This is the remote playground. When I execute when I run the command, I'm running this command to inside the Raspberry. Raspberry is doing the process. And I can open the remote browser, like I showed it in the video, to create a new class, modify something. And this is the code of PharoThings. I can show, like I showed in the video, the code of the Raspberry Pi, the boards, board B, revision 1, revision 2, there's the code of the Arduino, code of the sensors, code of the LCD. And I can browse it to the code and change and save all this remotely. I can open the process browser remotely too. This to me was very useful because sometimes I start some process remotely and I would like to stop the process, to kill the process. And I just open the remote browser, process browser, and kill the process and continue my work. It was very useful. And now I will inspect the board to show how I can control the HPIOs. So now I will create a new object using the GPIO22. It's one of the last GPIOs. And now I create this object. I will set this object like digital output because I have two options to set like output or input. I will put this like output because it's a LED. I will send the power to this LED. And when I send the message value 1 to the object, the LED 1, and I can use the code to control the GPIOs. And how this object, I can create methods to change the value like toggle digital value. And I can use this to control the GPIOs. And here in this vector is shown to me in real time how is the state of the object. Right? If I put the value 0 and now the output is red, showing the real state of the object. So now I will create one object with a button red. Okay, I will use the GPIO training type. I would like to show the GPIO. And now the button I set like digital input because we will receive the input, and I will set the state of the button and pull up the resistor, and And now I create a process to take the state of the button and send the state to the LED to show the LED, and I can control. And when I press the button, the LED is turned on. When I release the button, the LED is turned off.
Alex, we couldn't see the process. Can you scroll or? It's wonderful. Yeah, okay.
The size of the window is the zoom, something like this. This is the process. I run this process, and I can take the result of the button and send this to LED, and I can kill this process with this line, or I can open the process browser remotely and see the process run. Where is it? Yeah, here's the process, button process, and I can see all the process run remotely. And to me, this is very useful. And now I will show how I can use the sensors. To use the sensors is very simple too. It's like I create a new object to the model of the sensor, and I ask this object. Now I use the MCP9808 as a sensor, and I ask to read the temperature, and the temperature is shown to me. And the temperature now here is 22.3 degrees. And the same thing, I can take the coordinates of this another sensor. This another sensor is one accelerometer, and I can ask to it, how is the coordinates? And I have here the coordinates, 5,000, and this is the 3 axis. X, Y, and Z. So with this, I think, oh, I would like to create something to show something physical, and I can touch using PharoThings and use the code, and use the sensors, and use the stuff. And what I need to do now, and I start in the last month, create one code to one LCD display. I needed this code because I would like to create one mini weather station using PharoThings, and I didn't have the code of the LCD. And I think, oh, I will create this new code, this new driver to create this mini weather station, just to see how I can develop something using PharoThings. And I show the code of the LCD just to yes, and this is the LCD code. I can send a message to the LCD, I can control it, and I can show you. And it's very simple to control the LCD too. I just install, instantiate this, and I yeah. And when I send the message to LCD, the message is shown in the screen. It is shown them, hello everybody, Karlsruhe. And this is how I send the message to sensor. And it's very simple, it's very easy. It's just instantiate an object and send the message to it. And in the IoT context, this is very interesting because everyone can create stuff, can create codes and programs. So continues. In the slides, I have here some what I use it to do this. How you can reproduce it with this tool. In the first example, I used the one plus Bern in model. Now you can use any model plus Bern PI because I have code to all the models. And if tomorrow we release the model 4, it's just to write the code to the board. It's very easy to do this. And in this first example, this is the connection that I use it. It's like a mini tutorial. You can do this very easy. And this is the code that I use. And to play with the sensors, I use the sensors in this example. And this is the connection. The sensors use the I2C protocol to connect between Raspberry and sensors. This is the code, and this is important. When to do this in Raspberry, I need to change some files in Raspberry to allow the I2C connection, I2C protocol, and this is the code to run the sensors. This is the result, and this is what I need to play with the LCD. I use an LCD 1602. It's 16 characters in 2 lines. There's different models, and I can use the different models, more bigger or smaller. And this is how I connected the LCD. This is interesting because here in these 4 green wires is where I send the data to the LCD. I send the data using 4 bits. I need to take 8 bits, split in 2 parts. I send the first 4, and I send one clock signal using this wire. And after I send the last 4 bits, and the charter is shown in the LCD. And I use another wire to send commands to set the LCD if it's receiving commands or data. And This is the code to send a message to LCD to instantiate it. And this is what I created remotely, connected remotely in the Raspberry, and developed some code. I create this. This is very simple. It's only an example to show how I can do something using PharoThings. This is a personal mini weather station. What is to take the sensor data using Pharo, show this data in an LCD display, and I take this and send it to a web server, remote server. This is the charts. Here I send to the ThinkSpeak. This is the temperature on my office in India. This is the humidity and pressure, and here is the device. It's here. I put this inside the box to be beautiful, I think. But I will turn on this here to show how this works. And the concept is very simple, and I run PharoThings in the Raspberry Pi. I collect the sensor, the data sensor. I'm using the sensor PME280, and I take the temperature, the humidity, and pressure. I show this in this LCD, and I send this to a remote server. How I did this? I create one code to the LCD. I create one class to instantiate the LCD and to instantiate the sensor, and I create subclass to create process. This process print information in LCD each 1 second, and another class create another process to send the data to a web server. And here. It's not possible to see, but it's showing now the temperature, the humidity, and the pressure in real time in this LCD. And I run and do this in PharoThings, running this in Pharo. So good, but if you want to see this, it's just come here after the presentation to see if this works. Okay. And this is very simple. When I start the Raspberry, I call to the Pharo. I start Pharo. And I start this, I instantiate the new class, the two class, the display LCD in PostData, and I open, or I start the server too, and now I can connect in this device remote, and I can do changes, I can create new stuffs with the device running, and so you can create everything using this. And this mini web station is only one idea. It's just the minimum to show how I use the PharoThings, how I connect it in remotely work, how I save this, how I do persistence. And yesterday I went to a bar, and when I pay the bill, I see this. It's the same LCD using in the cashier. What this means, I can use Pharo to create a software and interact with this to the low level, and it's just create. And the future, the project and news, to where we are going, and we are creating new codes to new device like BigObon and small device, creating zero conf for INRIA and PharoThings, because we would like to put this to run with one line. You put in one command and everything is installed in your small device in Raspberry. We are working in remote refactory and improve the security on the PharoThings. Another project is the teleradar. Teleradar is one tool to detect the PharoThings and the network. For instance, if I will do a deploy in the environment with 100 PharoThings, the device Raspberry, how I can scan the network to see how is the IP to the device, how I can find the device. And this tool, the radar, is to communicate with this small device, and I can just click in the debugger, and when I click in the debugger, open the debugger window, and I can connect, and just very simple to find the devices in the network and connect it to do some changes and debug and change the program and updates and stuff like this. Another project is a middleware to control and manage this device. For instance, here it's very small, but I have 8 devices connected in this middleware, and I can see some statistics like what's the IP address, is connected or no, which the model is running Raspberry Pi 3B, Raspberry 2, Raspberry 1, which the version of the program is running, and I can see which the version of the Pharo, which the version of the PharoThings, and in this middleware I can see all the information on my network and my devices in this system, in the software. And we are working in this middleware. And one next step is one website, official website with main lessons and tutorials. And there is a draft. This is the address. I created these lessons because I would like to everyone can start with PharoThings in the easy way, and you can go to website and start lessons, and it's very detailed lessons, very easy to do. And in the future we will have the official website to do this. And yeah, we want to and with PharoThings, we can dynamically update your running board directly, remotely with pins and boards, modify the system while it's running, create new board, change the code, make your changes persistent, and it's very easy and powerful. And thanks for everyone here, and any questions?
From a technical point, it's really interesting. Only things like the teleradar or something like that scares me a little bit. Most of us have heard Jerry's talk a few days ago. So, what is done to avoid that everybody in the world can hack my devices, like easily as you showed?
So, teleradar is only for the local network, so it uses this subset of universal plug and play to discover machines. And of course, we need to have a security layer so that you need a password to connect. And it needs to be secure.
Does your remote Pharo runs under the 0 edition of the Raspberry Pi? Or do you need the full Raspberry Pi?
The Raspberry Pi 0.
0V or stuff, yeah.
So we have not yet tried on Raspberry Pi 0, but it should work.
Your slide shows the 0.
Yes, but
to the LCD display and that one.
so I think that was just because it fit better on the slides. So right now we use the Raspberry Pi 3 and the older ones, but we definitely will look at the Raspberry Pi Zero. But it should be compatible. So the GPIO is 100% compatible and it should work. What will be more work is to get it to work on BeagleBone, for example, because there the GPIO is different.
Yeah, I've done some work on Raspberry Pi with different things, and one of the issues there is that it mainly uses the SD card to run from, and if power is lost during the write action, the whole thing gets trashed. Is that a risk with PharoThings, or have you any thoughts on that?
What is the problem? That
The Raspberry Pi doesn't have a storage capacity other than the SD card. So I wonder, I've not enough experience with Pharo to know if that's going to be a problem. Does the image write often to the SD card? Or?
Normally not. So the idea that you this idea that you save the image on the running device is actually only what you would do in development and debugging. And normally the idea is that you have a kind of continuous integration where an image comes from that you will start up on the Raspberry Pi, and after that it does not write to the flash card at all because the image is in memory, and it doesn't need to do anything. And as you do not really, I mean, in development it accesses the sources file, but the changes file, but in runtime it should not have any access to it.
I would like to have views about memory consumption, and especially on the RPM, because of what is the status of the RPMs?
Right now we just use what is there, so we have not deeper looked into that.
So there is still the RPM?
No.
To avoid redundancies, I have an announcement. John McIntosh pushed MQTT implementation of knowledge further, and includes a data client, data broker, and such. And I also learned that Lam Research did similar implementations. So we will merge our code with theirs and push it back to the community. And I announced this so that nobody else gets started with MQTT. And does the same work. So if somebody needs it urgently, please contact John or me, and we'll give you some side.
If you take this some step further and not considering output stuff with it, but heavy input, changing rapidly, have you considered programming on it? So if the signal in background churns very rapidly and you want, for example, by a light sensor, and you want to control motors, you have to be very speedy to get short reaction time. How would you do this? So say, for example, if the signal, if there is some signal or event posted because the GPIO has changed, then execute stopping the motor, even if foreground stuff is running in Pharo. So stuff like this.
Right now, not. So right now we are on this level, but having some kind of better programming model for data and some kind of reactive way would be nice. But right now we didn't experiment with that.
What about
One last.
What about the power consumption? So would it be feasible to have such a device autonomous, like in a tree or in a little vehicle or something? And what is the Pharo contribution to that? So is it expensive power-wise to run Pharo?
I mean, right now you have the same problem like in the server setting, that you do have morphic running. You can turn the event loop down and it does not take that much CPU. But that's something that we want to solve with Pharo 8 when we have real headless. It should actually not take any energy. But I'm not sure if it really improves it to towards other systems? No idea.
I can sort of answer that. We've had PICE on battery packs, and they've all lasted about 8 hours, whether or not the Pharo server is running in the background or not. So that's the most behind answer. But the event loop doesn't seem to affect the overall battery time. In our case.